my God, that's us. Wait, so did we start? Are we recording right now?
Are we starting now? Oh,
We're recording. Okay,
Yeah.
this is great. So we
This
can
is good.
play with the camera to see if it follows
That's
us.
right.
Whoa. Sorry, this is automatically
Let's,
tracking us, which is
Yeah.
really cool.
Let's take a.
Let's not waste everybody's time here
Yeah.
with our shenanigans. We could do it at the
We're
end.
gonna
Let's
do.
it at the end.
Yeah. Okay.
Okay,
Let's do
fine. We're
one
doing it now.
together.
We're
Okay.
doing it now.
We're doing it.
Selfie. Look
One,
at
two,
us on the
three.
big screen. I'm still just like
Yeah.
in shock with this camera just following
It
us.
is.
I am determined to confuse it.
Yes.
Okay.
Okay. I think we're starting, right? Yeah. 3:40. Okay. Let's start. First of all, welcome everyone to come to our talk, optimizing speed and scale of real-time analytics using Apache Pulsar and Apache Pinot. So we are very happy to be here. Myself, I'm Mary Grygleski from DataStax, and then Karin Wolok from StarTree. So thank you, and I know you have many choices, but for you to come here, thank you very much. So we'll start. First of all, if you're interested in this slide deck as we're speaking through, if you're interested, please feel free to take a quick screenshot to get the slide. Also, or you can use the bit.ly link. So, yeah. Good?
Yes.
Okay.
I'm
10 seconds.
I'm just checking this camera to see how accurate it is. Oh my God!
Yes.
Wait, there you go.
Okay. All right. So I think it's all good. Even if you miss, don't worry about it. We'll be sharing the slide deck with the organization here. So, okay, let me quick introduction. I'm Mary, and I'm a streaming developer advocate at DataStax, which is a company, big data, Cassandra, Apache Cassandra, if you're familiar with it. We have the managed cloud platform, the Cassandra company, but that's more well known for that, right? No SQL, big data, database as a service now, and then now we're getting into streaming, so Apache Pulsar, and that's why I'm here to talk a bit about Pulsar. And then previously, I was a developer advocate at IBM with the Java advocacy team. I'm based in Chicago. I'm also a Java champion. Also, I'm the president of the Chicago Java Users Group, and so you're all welcome to join our meetups too whenever we have it online. If you don't mind the time, it will be late for you, but yeah. But we also have things on our YouTube channel too. I'm previously a developer, software engineer for over 20 years. So yeah, so I understand too where everybody is from. I'm assuming most of you are developers or maybe architects or technical architects. So yeah, so that's a bit about me. So, and then now we have Karin.
Okay, so I'm Karin Wolok. I lead the developer community at StarTree. StarTree is a fairly early stage, like startup company, fairly early stage. We're like, raised Series B recently, which is like, woo. And before that, I was at Neo4j leading the community there. I love those folks. They have a booth here, so if you stop by. Yeah. And yeah, so the story of StarTree, basically, I mean, some of you guys are probably familiar with like how Kafka started and Confluent. It's similar to that. Apache Pinot started at LinkedIn, and then the authors of the project started StarTree. And that's how it came to be. So I started when it was in stealth, and now we're like a company that actually can tell people our name, which is cool. And yeah, I worked in rap music before this. Like I worked for like Eminem and 50 Cent, so that was interesting going from that to tech. Did you know that?
I didn't even know it.
Oh yeah,
now
I was hanging out with Eminem and 50 Cent all the time. And yeah, that's basically my story.
Thank you, Karin. Okay. And then let's start with our agenda. So we'll start by talking about, discussing too why we need Apache Pinot, for example, to do like real-time analytics. And Karin will be telling us about, the kind of problems that Pinot is trying to solve and all that interesting kind of goodies about it, giving you a bit of a background about real-time analytics. And then we'll kind of like turn into like how can we actually, or how can we solve the problems? What can we use for solving the problems? And that's when Apache Pinot comes in. Plus also we have Apache Pulsar to help with the ingestion of data in a very fast, fast pace and also like high volume. And then I'll give you a bit of an introduction to Apache Pulsar, and then we'll go back to Karin kind of wrapping up to about Pinot a little more. Yeah, and that's our agenda for today. So we will start with the analytics use cases.
So I'm going to take the clicker.
Sure.
Okay, so generally speaking, I'm just kind of give some high-level overview, kind of foundation stuff for this, like just the use cases. So generally speaking, there are, three types of analytics use cases. So the first one is the most commonly known and most widely used, which is like dashboards and BI tools. Most often, it's used for internal purposes, and BI analysts are the ones using these types of analytics. The second one is things that are machine learning. Why is the image not showing up? Sorry, I keep clicking back and forth. So machine learning, this is basically any type of analytics that are then fed into a system to do the processing. So think if you have like automated fraud detection or anomaly detection, things like that, that are machine fed, and then the machine does the analysis on it. So that type of analytics, so you have that. And then the third one, which we're going to dig into the most during this presentation, is user-facing analytics. So user-facing analytics is essentially when you are providing your end users or your customers of your applications with their own real-time analytics. So this is an example of one. I'm also going to dig into a couple use cases to really kind of open up this window of like what user-facing analytics is and the enablement of it, or like some of the cool stuff that you can do with it. So one thing I want to talk about really that's I think is pretty important as a takeaway for user-facing real-time analytics is actionable insights. So when you are providing your end users with real-time analytics, you could provide them things like dashboards, BI tools, or dashboards and things like that. But what a lot of organizations are doing are actually enabling their end users to take action or some kind of movement based on the real-time analytics or insights that they get. So I think this is an important takeaway because, and I'll give you some examples and show you how like organizations are doing this, but this is really enabling your user to a much higher level where like also the importance of it being in real time is pretty important, you know, when people are actually taking action upon like seeing analytics or insights. So why should you care about user-facing real-time analytics? So it used to be that back in the day, all analytics were being used for internal purposes, and the same thing kind of what I was talking about with the BI analysts, and it still has a lot of value there. But as time progressed, organizations started giving their end users and their customers access to their own analytics. And it's been so effective that some organizations have even productized their real-time analytics to their end users. So they'll either create premium features or capabilities by giving their end users analytics. Sometimes there's full organizations that are literally structured around giving end users analytics and providing them with the ability to do actionable insights. So I'm going to dig into a couple pretty wide-known use cases around user-facing analytics. So the first one is LinkedIn. LinkedIn has user-facing analytics all over their site. Probably the most commonly known is the Who Viewed My Profile. I'm assuming most of you guys have had the experience of using this. So it gives you the ability to see who viewed your profile. Users also have the ability to slice and dice this data by geography or company, things like that, right? So this is an example of user-facing analytics. LinkedIn is providing their end users with their own analytics. Then the users, they're talking about the actionable insights, then have the ability to take action of some sort. They can connect with someone, they can follow, whatever, look at somebody else's profile. But it's really important that this information is all in real time. Another example of user-facing real-time analytics, this is more of like the user-facing, the real-time analytics systems. So this is kind of a little bit offbeat, but the newsfeed, basically every time a user refreshes their page, they have new information in their newsfeed. It has to be fresh and it has to be relevant, and you have to make sure that it's not content that they've already seen before. And this gets quite complex when you have 800 million users on your platform and they're constantly clicking the homepage, and you want to make sure that all their information that they're seeing is fresh. Again, they have the ability to take action. They can like, comment, share, things like that upon seeing the relevant information. Another example of LinkedIn productizing real-time analytics is, I don't know if you guys, unless you guys are recruiters, you probably have not seen this, but like your talent pool, like the recruiter insights. This kind of gives recruiters a high-level view of what's going on in like the work like ecosystem, I guess. And this is it's quite complex to build these types of things when there's information that's constantly changing, right? So there's a lot of fresh data coming in, and they have to be able to show that to the recruiters, who then have the ability to take action. Another example. Sorry, the clicker is a little bit weird. Okay, another example of user-facing analytics is Uber Eats. So Uber Eats is a platform with over 500,000 restaurants that use it, and the restaurants have the ability to manage their deliveries and their restaurants and their orders using the Uber Eats platform. So as you can see here, like this is kind of like the example of the dashboards. You have missed orders, inaccurate orders, feedback, things like that. Now, when we're talking about the actionable insights of like why it's so important for the users to have real-time analytics in this and also be able to take action is, let's say a restaurant owner sees all of a sudden there's menu item feedback are down, or there's inaccurate orders or missed orders or something like that. They can then take action right away. So like if there's something happening, maybe they need to send everybody $10 coupons. Hey, I'm so sorry, this is late, blah, 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 whatever. They can't find out tomorrow, right? That customer is already probably long gone and probably gonna say, I'm never using Uber Eats again. So this is kind of like the example of like when you can use real-time analytics and build actionable insights in there to provide more value for your end users, productizing all of it. And then the third example is Stripe. If you're not familiar with Stripe payment processing system, this is, okay, yeah. So they have a bunch of different real-time analytics use cases at Stripe, but I'm gonna talk about one specifically, which is this one. So Stripe has dozens of engineering teams that are all working on different parts of the platform. And then they have to be able to take all this information of all these different things that the engineering teams are working on, bring it into one consolidated view, and then make it accessible to a bunch of other internal teams. So like the accounting team, data science, the finance team, things like that, right? So like they have to be able to ingest all these data that all these different folks are doing at the company, bring it in at all, and then make it accessible to all these other people, which is really complex to do. And because it's a financial payment processing system, there's like a lot of regulations and like sensitivity to the data and the accuracy of it and all that kind of stuff too. So this is quite a complex problem. This is not as much of a user-facing analytics. It's more essentially like your internal users, but it does have the same requirements as building these real-time analytics systems out. Okay, so how this is cut off, this image. It doesn't look like that. I'll go back to it. There we go. There we go. That's what it looks like. Yeah. Okay, so how is user-facing analytics? How has it changed in terms of like the requirements and things that have been needed over time? So it used to be when organizations were using this internally, it's latency seconds. Freshness is seconds to minutes. Concurrency is hundreds of people, whatever. But as it's grown, and now that organizations are offering these real-time analytics to their end users, things are getting a little bit more complex. The latency needs to be in milliseconds. Freshness needs to be in seconds. And the concurrency is sometimes millions of users, right? Some of these platforms have a lot of people using them. So evolution of real-time analytics. This is also a little bit about how the systems have needed to change and adapt in order to be able to meet these new needs. Just going from structured data to semi-structured data. They have to have strong data and query consistency now, full SQL semantics, and obviously like the size of data is just tremendously growing. So to be able to support all these things, you really need some powerful tools to build this stuff out. Okay, so building a user-facing real-time analytics system, there's essentially three kind of components that you need here. The first part on the left side, the green, I don't know if I have to say left side, I don't know, whatever side that is over there, real-time ingestion, is the ingestion side of things. So like your speed of ingestion has to be optimal, right? Like you have to be able to bring data in very, very quickly. And then over on the other side, seconds freshness is you also have to be able to pull that data out and make it queryable very, very quickly, right? So pulling data in and then pulling data out very, very fast. There's also obviously things in there like dimensionality and things like that, but those two components. And then the third part is that it has to be scalable. Like you have to be able to do this with like high concurrent queries coming in at the same time, right? So it's pulling in a lot of data at scale, pulling out a lot of data at scale with a lot of dimensionality. So I'm gonna let Mary explain a little bit about the one side of the system.
Okay. So now that's why too we are coming together to do this talk, because we find it it's going to be very promising using like a combination of these two technologies together. Also like open source, Apache, and so we're excited to talk about it. And actually both our companies are in partnership too, to talking about more things that we can build together. So okay, so back to here then. When it comes to real-time ingestion, actually let me ask you, how many of you have heard of Pulsar? Apache Pulsar. Okay, how many of you are already working with Pulsar? Maybe? Okay, maybe one or two. So yeah, so here this talk isn't specifically about Pulsar, but we'll give you a taste, an introductory taste of it, as to why it would be like prime example of a good, you should consider it using, if you're using it for fast, like event streaming type of purposes. So, and how many of you are already using Kafka, may I ask too? Okay, so more of you are already using. So yeah, they're actually talking about which too. There are people asking me, oh, is it Pulsar is Kafka on steroids? But I think it's more about, Pulsar having the cloud native DNA in it. So it's really like built for the cloud environment. So, okay, so yeah, it comes back to here about real-time ingestion. We're suggesting you to use Pulsar. And let's kind of take a look into Pulsar in here. So over here too, we're kind of looking at this. This is actually just a quick diagram first. And Pulsar, it makes use of a pops-up type of approach, right, to managing all of the messaging. And then it will rely on broker. By default, it's, somehow it isn't showing up. Yeah, sorry about that. So yeah, so there's producer, consumer, and then send, messages are handled by the broker. And then two is that over here, you see additional things. When we compare with Kafka, the difference is that Pulsar doesn't manage its own log messaging. As we all know, when you're dealing with, like asynchronous messaging, high volume, kind of messaging systems, Pulsar has actually decided, well, I'm not going to deal with all those high volume of log messages, and I'll let Bookkeep, which is Apache Bookkeeper, to handle all of it. And then there's also Zookeeper, too, that it relies on to help with like managing the clusters and all of these things. So this is kind of a quick overview first, but let's kind of get more into, again, event streaming first. Just want to explain too what's driving this change. But as such, we are already talking about. Is it?
Yeah, we just go forward and back, or back and
That's right. And not sure why it isn't refreshing. So okay, so this part I'll just real quickly. The reason why we want to consider like a tool like event streaming fast and everything is because we want data to be real time. And also, too, it enables you to build data pipelines. You can actually build pipelines of, data flowing through like multiple, kind of flows of your system, too. And you are not, kind of confined to using, for example, if you're using JMS, and presumably, right, then you can only write in Java client to kind of do all the work. But here, you can actually have .NET client or Go or whatever, right, that it supports. And so you can use it for building data pipelines. And it's also can be, you can thought of it to use for your artificial intelligence projects or machine learning type of pipelines. And also the scalability aspect too is also very good, because using pops-up type of approach. Here, I won't kind of get into all the details, but let's also kind of step back a little bit, looking at streaming. There are also, like, before doing event streaming, if you look below, right, if you're not using, like, a true event streaming, then you would be ingesting data, and then you persist the data to some data store or database, and then you have to do more selection afterwards, and then process it, and then write it back to persistence somewhere. So as you can see, it will involve a lot of steps in terms of doing all the I/O, disk I/O. So naturally, it will kind of take more time to do it. Whereas if you're doing kind of like true streaming over there, you can actually ingest the data and then do the processing, everything in memory as well. For example, or sending it over to Pinot. Pinot will do things, in its very fast indexing way that Karin will be talking about. And then too is that you stream it, and then you send all of the results of your data after it's processed to a sink. and you can build your sync, in different kind of pre-configured kind of manner too, which I'll talk in a second. And then from there, you can do all of these, kind of processing, calculation, all in memory as well. So that's event streaming, and let's then talk about Pulsar. So what is Pulsar? Let's give a quick introduction. It was created by Yahoo in the early 2010s because at the time they weren't, able to find any kind of available library to kind of do the event streaming that it needs to, especially in the cloud. So Yahoo started doing its own Pulsar. And then in 2016, it donated it to Apache Software Foundation, and very soon in 2018, it became a top-level project. And it's very cloud-native in nature or by design, cluster-based, and also supports multi-tenancy as well. And again, I talk about too, it doesn't manage the storage itself. It delegates it to Apache Bookkeeper to manage all of the storages of all the log messages. And it handles Pulsar can then focus on doing all of the compute, working with the broker, essentially. And then you can write your client essentially using Java. You can use .NET client or Python or Go. And there are also community contributions, such as like Scala clients are also supported, but they are more community kind of contribution too. Also, too, Pulsar also guarantees your message delivery because anytime you do asynchronous messaging, it's also harder to track and everything. But with the Pulsar broker, it guarantees that your messages gets delivered exactly once, or you can set it so then it delivers at least once. All of these, the quality of service delivery are guaranteed. Also, too, Pulsar has this serverless functions framework that you can use for doing message transformation as well, and all done kind of within the Pulsar cluster. It also has a feature called tiered storage offloads that when data becomes cold, then it will be offload to cold storage, so it doesn't take up room in the hot storage kind of area. So that's kind of a quick summary of Pulsar first. And again, this is just a slide to introduce to you. It is a unified distributed messaging and streaming platform, open source, and very cloud native in nature. And you may be wondering, too, who else is using Pulsar? So these are the different kind of major companies that are currently using. And in fact, Splunk is also here as a sponsor for the event, and they are also supporting Pulsar, and also participating in the Apache Pulsar project, too. So yeah, so these are the ones. And then just wanted to kind of summarize again, Pulsar, these are the components. You write code, you write the producer that will be sending messages to the topic, right? And pops up, by default is this one broker, but the thing is you can actually, most of the time you want to use multiple brokers, plus too, the topics too can be partitioned, so then this will increase the throughput of your message sending and kind of, the sending side. And then there's also consumer. They are the ones that will be reading messages from the topic too that are managed by the broker. The broker itself is a stateless process. It is written in Java, and it handles all of the incoming messages and also message dispatching, communicates with the Pulsar configuration store and all of these things, and it stores all of the messages in the bookkeeper instances, all of these work. And then the bookkeeper is the one that manages all of the persistence of all of the message store, while Zookeeper will hold all of the cluster metadata, handles all of the coordination tasks between Pulsar clusters too. So, okay, so this is just a slide to explain too. Pulsar takes on this traditional multi-node architecture in here. As you can see, right, and anytime you're kind of dealing with multi-node kind of architecture in the cloud, and the one big challenge, one of the challenges would be what to do, right? If you are scaling your systems, you are adding another node, adding another server to your whole infrastructure, then all of your brokers, what to do, right? You already have multiple brokers handling many topics, and they're all partitioned, into handled by different brokers. So in this case too, the nice thing about Pulsar is that it manages all of the auto scaling for you. and it manages like rebalancing all of your topics in the different nodes for you. So then, as a developer, you don't need to worry about it. So that's kind of one good thing about it. And plus, two, is that all of the kind of persistence and messaging, they are all loosely coupled. Yeah, right. Your sender of your messages, you use PubSub. You don't need to worry about the address of your receiving side. It's all handled by the broker. You're labeling all of your messages as topics or router, some kind of channels. So then the broker will deliver accordingly to whoever the clients are interested in subscribing to the topics. So that's kind of essentially what it is, and it's also multi-node architecture as well. Here too is a slide to show you a little more about that the architecture. As you can see, even for the bookkeeper side, bookkeys, these are individual operating units of Apache Bookkeeper. It will segment off all of your log messages, so then they get all kind of spread out kind of evenly too. And it helps with the load balancing part. And then also Bookkeeper also follows this wall spec, which is a write-ahead logging spec that it guarantees all of your messages are all keeps its integrity, and then before it's being written to disk. And if you need to read it back and write it to it, it's very highly efficient as well. And you can also tune the consistency and also the message replication, all of these things. So having kind of Bookkeeper being there to handle the log messaging, then it makes the scalability aspect very easier to do, because when you need to scale, then they are all independent units needs to scale together rather than one unit controlling everybody. So that's the idea. Okay. And here too is just a diagram, just explain to you too, if you're already in an environment that you're using, say, some older architecture, like using JMS or using RabbitMQ, you don't necessarily have to change it. You can actually have Pulsar kind of bolt on top of it, so to speak, and you can kind of use it like that. So it's very flexible, because the way you can handle it, you can write your data pipelines for data to kind of flow through it. So Pulsar is really a unified solution for PubSub. You can do PubSub and also queuing as well, which I'll explain in a second how you can use Pulsar as a message queue as well. And then also helps you with streaming and also the message mediation and enrichment. So out of the box, capabilities, you can kind of have cloud that you can do on-premise or hybrid. You can do geo-replication as well. It supports that. And also multi-region support and data lake. And for example, now working with Pinot, different types of kind of use cases for Pulsar. So just some explanation of some what differentiates Pulsar, right? Let's say with another event streaming platform, messaging platform such as Kafka. Again, right, it's the separation between compute and storage. So these are all distributed messaging systems, and so Pulsar doesn't want to deal with managing all of the log messages. So it's handled by Apache Bookkeeper, and also Bookkeeper itself is segment-centric, all of the message storage. So it helps with horizontal scaling. So that's one. And then another thing, the second differentiator is with it being, supporting geo-replication. Say, for example, you have data center in different continents of the world, and you need to, replicate all of your data across different continents. So that's also supported, and it supports modes such as active-active or active-passive. You can do synchronous or asynchronous kind of patterns. It supports it. And also, too, let's say some regions you have data that you don't necessarily want to replicate across all regions. Let's say here in GDPR in Europe, you don't want to replicate all the data across all your servers all over the world. Then there's also, it supports selective message replication as well. So that's kind of a really nice feature that as developers, we don't want to worry so much about these infrastructural type of concern. Then there's also a third point about this is it supports multi-tenancy. All of your messages, you basically can organize them, in a cluster. You can organize them by different tenants of managing your company data structure. You have finance department or engineering department, marketing department. You can kind of demarcate all of these boundaries of the different areas of data too. So that's also very good feature that it already has coming out of the box. Okay, so that's that. And then one more thing is basically the very flexible message processing model. I mentioned about Apache Pulsar. You can use it as a message queue, and for this you actually will have to handle things on more of the subscription side. So there's this. There are 4 modes of subscription. You can do exclusive mode, which is you turn it into sort of like a message queue, because you only specify one consumer to receive messages for that subscription. So effectively turn it into one-to-one, point-to-point type of messaging. So using that exclusive subscription, you can turn that into a queue. Or you can also use a failover mode, which means that you have a primary consumer in your subscription, then you have one or more consumers that are kind of secondary, so that if the primary doesn't work, then one of the secondary will take over. And then there's also a shared subscription mode, which is like multiple consumers for that subscription. And then if you need message ordering to preserve the order of it being sent out, and then you want to make sure it's being delivered in the order it was sent out, you can use a key shared mode too, and that will support message ordering in a shared subscription mode. Okay, so that's that. And then I just want to highlight a couple of Pulsar developer features as well. And as such, these are just some of the features, right? There are more than just this. Okay, so about data pipeline, right? When we talk about building a data pipeline, is that we need a source of data. So in this case, right, like in a Pinot kind of cases, that's what happened. We act as the source. We provide all of the data, for Pinot. But the thing is too, with Pulsar is that there's also Pulsar function that you can do all the massaging that you need, right? Going through it. And then when you're done with massaging all of your data, do all the transformation, then you output it to a sink. The sink is where you collect all the result of all of your transformed data. So that's what like a data pipeline is like. And then it's nice because then you can kind of design your system as a series of different data pipelines, and you can have a data flow through your systems quite efficiently that way, right, for example. And you can basically use Pulsar functions. Pulsar functions currently supports Java client and Python and Go right now, and it's very lightweight too. It helps with like message, again, with transformation. As you can see, right, they take in input messages and Pulsar function. You can apply, you can write the code. They're just an SDK, you can write the code. And then basically to output it to a sink or to another topic as well, based on this example here. Okay, do I have time? Okay. Okay, then another, okay. And then another feature is called Pulsar schema. So essentially too, we know when we write code that needs to send, asynchronous sending over the wire, you need to serialize all of your data, your objects, flatten it. And the thing is, too, with Pulsar is that if you don't handle this, if you don't rely on something like Pulsar schema, then you have to serialize it yourself. And basically, you need to convert all your data to byte arrays, and then send it over the wire, and it comes back on the other side. You have to convert it back from byte array. However, Pulsar has a feature called Pulsar schema, so it supports you to describe your data using schema, and the different types include like primitive types, key value pair, or Avro or JSON or protobuf here. And it also supports the versioning of tracking all of the changes in your schema. So you can consider using Pulsar schema as well. So that's a very convenient type of feature here. And then there's also a Pulsar I/O feature. This I/O feature allows you to write your own connectors. So basically, like you're building your data pipeline, you can have different sources. For example, right now, there's even like Debezium sources for change data capture. There are already like pre-configured connectors for that. And also, I think there's also JDBC, some database like connectors. But if you need your own connector that isn't already configured, you can actually write your own connector too. So the sources, or you can write the sync connectors as well. So you can kind of check into Pulsar connectors to do that. Okay, and then now because I work for DataStax, I thought I'd just introduce to you. At DataStax there, we have managed Pulsar platform, but here today we may not have time to demonstrate it, but otherwise too, there's a managed cloud platform called Astra Streaming that also works with our Astra database, which is the managed Cassandra platform too. And then there's also Luna Streaming, which is you manage your own cloud. You write your own Helm chart, for example. You can deploy it yourself, but you can then kind of purchase our enterprise support too. And then if you want it all open source, it is also there. It's very community-driven, Pulsar. Okay, and then we are now back to this part. And you want to continue?
Sure.
Yeah, okay.
Okay, so I'm going to run through this pretty quickly, and if any of you guys have additional questions about it, there's so many resources online, so just Google it. Okay, so the other side of building your real-time analytics system is Apache Pinot, which is what I'm going to dig into. So Apache Pinot was originally built at LinkedIn. And what it is, it's an OLAP distributed data store. Essentially, it is built to pull in data from a variety of different sources, push, from batch or streaming, Hadoop, S3, Pulsar, Kafka, whatever, and then pull them into one kind of aggregated view, like a merged view of like batch and streaming data, historical and real-time data. It has a lot of very powerful indexing in there, and then it makes all that data queryable on the opposite end with very, very high throughput with very low latency. So high concurrency, low latency. So that is Apache Pinot. And talking a little bit about Apache Pinot architecture. So first, there's the Apache Pinot servers. This is all like inside the Apache Pinot cluster. You have your Pinot controller, which basically manages the entire thing. Zookeeper managing your metadata. The Apache Pinot servers. And then you have the Pinot brokers. So I also do have the Pulsar thing. Let's see, but okay. So your Pinot brokers essentially take in queries from the client. They use like an intelligent scatter gather method across servers. In some cases, with one server, it has like a way of like mapping things out to like have like a least amount of compute and storage capabilities, which is like, it gets really pretty intense with this stuff. But and then the query comes back out through the Pinot brokers back to the client. So when you have things like Pulsar, you have like Zookeeper, which basically creates a mapping of segments to servers, and then stores it onto the Apache Pinot servers and then makes it available for queries. Hopefully that, I know I'm giving like a very high level overview and I'm kind of rushing through this, but again, if you have more questions, there'll be more resources at the end for you to dig into. So some of the really powerful stuff in Apache Pinot is its indexing capabilities. So it has a lot of like standard indexing that you're probably pretty familiar with. So like at its heart, Pinot is a columnar store, but it does have support for JSON and text index and geo, and there's like aggregation optimizations, and there's also the StarTree index, if that name sounds familiar. And I'll dig into that just really briefly also. Also, people really love the upserts thing. So upserts, basically the ability to do real-time insert, updates, and delete. It's like a pretty big deal. This was created by the Uber team. So it does also support that, which is pretty amazing. And the StarTree index, so the StarTree index is kind of like this happy medium between latency and storage space. So it has kind of like, essentially you're kind of providing a threshold of like, when you're like running queries, you're basically creating a threshold. So like it's kind of like, I mean, you'd have to like read into it because it gets a little bit complex, but it kind of optimizes for storage space and for speed. And there's also a lot of optimizations you can do on the stack level through storage, filter, and post filter. And just talking about Apache Pinot community, sorry, really quick. Apache Pinot community, it's a very mature product, and it's used by hundreds of companies all over the world. The community is growing really rapidly. And at its largest, the Pinot cluster, this example is specifically pulled from LinkedIn, but it is, this is like, I don't mean to brag, but I'm going to brag. I mean, I didn't build it, but so it ingests like over 1 million events per second with a query speed of over 250,000 queries per second while maintaining a millisecond latency, which is pretty performant if you know about these numbers. And yes, and if you are building a real-time analytics system, Pulsar and Pinot make for a great combination.
Yep, that's right.
And yeah, I'll
do
let
we
you
have
take
it?
this one from here.
Okay, so I guess then we're ending this talk, but before we end, we just want to share with you a couple resource links if you want to search for more information. Because the session's here a little short, so I'm not able to actually do demos. Otherwise, demos is going to take a bit of time.
Yeah, she was working on that.
Yeah, I was working.
So yeah, that's the Pinot, the Apache Pinot
That's right.
site, and also dev.startree.ai. It has a bunch of resources in there, and you can also join the Slack if you have questions.
That's right. And then for Apache Pulsar, too, here I'm sharing with you the Pulsar, apache.org, and Bookkeeper, as well as Zookeeper links. Also, too, wanted to show you DataStax. We have our Astra DB, and I mentioned about that being a managed cloud platform. You can actually log on and get like $25 credit too, without giving you your credit card. So that's a nice thing. Actually, if we have time to, I can also quickly kind of show it to you, so you can start to play around with it. Like if you want to use our streaming, you want to use our Cassandra, that's $25. It's pretty good, actually, pretty sufficient too for like personal projects. So that's astra.datastax.com. Then there are links to Astra Streaming, which is the Pulsar underneath the hood, Astra Streaming. Luna Streaming, as I mentioned to you, that's the one that you can use for like deploying your own into your own cloud too. And then there's also this feature. I'm not doing that talk here, but I have this talk called Change Data Capture that we support too in Cassandra, but that's using Pulsar underneath the hood too. If you are ever interested, also let me know. Then there's this, if you want extra credit, right? Open source 200 is the code you can use, and that link to get $200 additional credit. Also too, what was I going to say? There was something else I wanted to say. Well, if I remember, it's like I'm thinking and talking at the same time, and then okay. Anyway, so there's also too, if you are interested, right, in some kind of short videos on each topics about Pulsar. Here too, on this particular link is actually we label it. We call it 5 minutes about Pulsar. So different topics like how do I write a function, a Pulsar function in Java, for example, right? Topics like that, or like about subscription mode. What is it about? So there's a really short and sweet kind of a quick video that you can find on our Astra Streaming YouTube channel too. It's actually DataStax developers channel, but this is the link if you want to reach that. So to just learn about different nuggets of each piece of functionality, so you can search for that. So. Also, too, actually, that's the thing. Today, I'm not able to do live coding, but I actually have a Twitch stream myself. So normally, I would do it if I'm not on travel. If I'm home, I would be doing it every.
It's very rare when she's home. She's always on the road.
Yeah, it's
You
now
live a rock star life.
Yeah, well, I hope, I wish.
She was just in Morocco at a conference,
Yeah.
but by the pool.
Oh, that was the only one. But anyway, so yeah, if I'm not traveling for conference, I will be doing my Twitch stream. So I will be doing live coding on there. This is the link to my Twitch stream. And normally I do it on Wednesday, like afternoon Central Time. I may actually be able to do it here because I'm free tomorrow, so I may actually set up shop out here and just do a live stream.
Never free.
Yeah, I know. Yeah. Okay, so yeah, and I invite folks too if you want to join. Right, it's a very interactive session. It's intended for you to also join me if you're interested to show me your project. I invite people to come and join my stream too. So I'm open to that. So yeah, every Wednesday afternoon. Although that would be evening time here. So. Okay, and then some additional information about Pulsar. If you're interested, there we have meetup groups here, and also like a wiki page, Apache Pulsar neighborhood too, that you can look up more information or you can contribute to that as well. And then with that, we want to say thank you to you. These are information as to how you can keep in touch with us. And again, I have my Twitch stream too, but also I have LinkedIn, so is Karin, our Twitter handle. And also I have a Discord channel too, if you want to keep the conversation going. Again, share your information, share your project with me. So thank you. Yeah, thank you very much. And that's why I was going to say, if you're interested, I can quickly show. Do we have time? Like 7 minutes?
She also has stickers here.
Oh,
I want to say that
thank
before
you.
she forgets.
Thank you. Thank
This
you
is
very
from
much.
when we met, right? That picture was when we met.
Yes,
Did we meet that time?
that's right. Yeah, this
That was
one.
the first time.
Yeah, we first met, and that's how we decided in Zurich. We were at Vox Days, Zurich.
And we're like, let's
Yeah.
partner up and do
Yeah, let's do a talk together. So that's why we're here too. But we took this picture in Zurich, yeah, over there. So yeah, And would you like to take a look at Astra streaming or Astra, the quick thing, right?
You got some nods in there.
Yeah,
So.
I-
Yeah.
but-
Show a demo. Do a live thing.
live thing, yeah.
Something live.
Okay, yeah. I have too many tabs here, but yeah, let me kind of quickly show. So if you go to astra.datastax.com, so you'll get a screen like this. Let me kind of increase a little bit. Yeah. So over here, again, if you want to sign up, right, at the bottom here, sign up, that's all you need. You don't need to give your credit card. Just give your email address and your name, and then you can log on. But in my case, I already have one, so I sign it with my Google account. So, all right. It may take a little bit of time, but otherwise too, you'll be brought right to the dashboard here. And so on the left side, as you can see, if you are interested in our managed Cassandra, there's also a lot of good things in there too. You can create your database, and then that's Cassandra. And then also we have create streaming. This would be the one for Pulsar, our Pulsar kind of support underneath the hood. And you can just create this by tenant. So you can say, okay, here is DevOps BE, and then you can kind of select Google Cloud, and let's choose Austria, right? Or no, Australia, Europe West or something. And then it will show you how much would it cost, right? Like the write cost and read cost. And as you can see, it's not too bad. If you're doing personal projects, it's very much sufficient for a month. And then you can create the tenant, and then it's right there. Now, in this case, let me kind of really quickly show you a topic that I've already created for doing some testing. So this thing is POC tenant. This is one of my, actually I should say my tenant. So over here too, it's very nice because this is just one way of how you can use Pulsar that I want to share with you. So if you want to get started with Astra streaming, everything is managed cloud. So over here, it already shows you how do you get started. You create a topic, right? So if you create a topic, you go to the topic, and you're brought to the topics kind of menu. And over here, you can just say add a topic, and it's as simple as I can just say DevOps BE, for example. I want a persistent topic or partition and all these things, and let's say persistent and not partition. So, and then immediately it gets created, a topic, and if you click on it, it actually, once you use it, it will show you all of the statistics too, and that's the nice thing. So now, then you'll be wondering, now I have a topic, what do I do with it? Go back to your quick start, it will say, I want to produce data. Then you can go immediately to over here, connect. So the connect here will show you already all of the name of your tenant. Broker service URL is how you can connect to your broker. And then web service URL is an HTTPS connection, and that's for your admin, your Pulsar admin or Pulsar command line client too that can connect to your Pulsar broker too. And also if you want to use WebSocket, there's also WebSocket connection. So these are the URLs. And then if I, let's say this is Java conference, so I'll take a look, want to just get some, way to jumpstart, then you can look at this. There's Maven or Gradle definition is all listed here. If you want to do a producer, so producer client is an example in here. It's as simple as you make a connection basically to your, to a client, get your client handle, all these things, and then you, of course, give your URL for connection, all these things. And then once you have that, then you can set up your producer. Your producer, you just need to associate with the topic and then create, and your producer is there. When you're ready to send your messages, is essentially just do a producer.send. And that's synchronous send. There's also asynchronous send, for example. And then because I'm not using Pulsar schema, then I can just do a get byte, so it will convert your data to byte array. Remember, I talked about if you don't do that, you have to essentially take care of your own serialization. So over here, once you send your data, you can close it when you're done. Now, on the receiving side, you can write a consumer, the subscriber. Subscriber, likewise, too, you connect, you set up your client handle, and all of these things. Of course, there's authentication, but I'll show you where to get all this information in a second. But otherwise, too, for your consumer, you associate with the topic that you want, set up your subscription name, and then subscription mode, that one of the 4 modes. If you don't do that, then it's I think that's like an exclusive mode. Okay, and then when you're ready, you just loop around because you are subscribing to a topic that may or may not have data yet. So you need to subscribe and sit and wait, and when their messages comes, then basically it comes, then it will acknowledge this set of code, within the if clause, this loop will get executed, and you can then acknowledge your messages. And when you're done, you can basically close your consumer. So that's kind of like a real quick way of showing you how do you write a producer and how do you do a simple consumer in here. Okay, and then there's also one note about this is that Pulsar, for Pulsar, you can actually use a cursor to go through the log messages and do all the read, all the messages have been delivered. They are still there. They are still being retained. You can use a reader interface to kind of go through your log messages and read them back to using the cursor. So yeah, so that's kind of essentially, that's it, right? We have 1 minute left, so perfect. So
this is like after you see the movie credits and there's always like something at the end of it. You're like, do we wait until the end of the movie credits?
Yeah, thank
That's
you.
what Mary just
That's
did
what I
for
was
you.
thought yeah. Okay, cool. So that was just really quick. But if you follow my Twitch stream, I'll have more kind of actual coding in there too. So yeah, so I think with that, then yeah, we're all done with today's presentation, and thank you so much again for coming and joining us here. We're very happy to be in Belgium, and just amazing experience. So thank you, everyone. Feel free to ask questions anytime. So, and stickers are here too if you like some stickers. Yeah. So.
Only Pulsar stickers. I didn't bring Pinot stickers. I'm sorry.
Oh yeah. Okay. Thank you. Yeah.